Right, good morning everyone and welcome to this webinar on the challenges of 61850 simplification. My name is Mandana White and I'm the CEO of Smart Grid Forums, an independent conference organizer specialized in the European smart grid sector. Now today we'll be hearing from three leading industry experts on 61850 and then we'll be opening up the session to Q&A to give you the opportunity to gain complete clarity on how best to manage the complexities of transitioning to a 61850 enabled digital substation environment. I think we can all agree that introducing 61850 brings about many benefits and cost savings in the substation design, interoperability between vendors, commissioning, operation, simplification of cabling and reduction in devices. But there's also no denying that the complexity does not disappear altogether. It simply transfers to other areas such as network configuration, computers, virtualization, network security, and so on. So the question that we'll be addressing today is how can we best leverage 61850 simplification whilst also managing this transfer of complexity? Our speakers today are Edwin Mellenhorst, product owner at Locamation, Zenner, managing director and CTO of Welotec, and Jérôme Arnaud, head of product management at Rhebo. Each one of our speakers will present for around 15 minutes, and then we'll take questions for each speaker at the end of their presentation. We'll then wrap up the session with some final questions and panel discussion. We're aiming to complete the webinar by 10 a.m. So with that, I'd like to welcome our first speaker, Edwin Mellenhorst, who is product owner at Locamation. So Edwin, thank you for joining us, and over to you.
Yeah, thank you, Mandana. Very nice to be here. So yeah, I will be talking about if you go digital, why stick with the old concepts of many IEDs and merging units for process bus solutions. So if we can advance to the next step. Nowadays, it's very common to use multifunctional IEDs. Many of these IEDs integrate process functionality like TCTR, DVTR, and substation functions like measurements, control, switchgear, protection functions, and they all do this in a single box. Some of this functionality is not needed and therefore unused, but yeah, you pay for it nevertheless. Also, having many merging units and IEDs installed in a substation results in additional copper wiring and more complex network infrastructures. And now 61850 is designed to allocate substation functionality freely. It's no longer needed to have a TCTR, current transformer, protection functions, or control functionality in the same box. They can be physically separated in different applications, and they communicate over the network. This enables more flexibility in where these applications can be installed. For example, TCTR can be located in a sensor, and a PTOC, protection function, can be installed on a central substation computer. And now don't forget an application that implements a specific substation function, for example, a PTOC, does exactly the same and performs just as well or maybe even better as its counterpart in a traditional IED. In the end, it's all software. On the Substation Server, applications that implement functionality can be separated by use of virtual machines running on some platform with a hypervisor like the Linux Foundation for Energy, CPATH. The next slide, please. In this example, we see a conventional process bus solution with merging units and IEDs. And each of these merging units provide a sampled value stream, and the IEDs use these streams for their protection functions. Often a single IED is used per bay. Apart from the needed functionality, these IEDs might also contain unused functions. And because some process functionality is also located in the IED, additional copper wires might be needed. In general, it can be stated that more devices means that the overall mean time before or between failure of the substation is shorter. Also, exchanging complex IEDs in case of repair might take more time, which means that the mean time to repair is higher. Next slide, please. When functionality is allocated in a more central point, like a substation server, running applications in a dedicated virtual machine, less hardware is needed. This makes the physical design of secondary systems less complex. Some functionality still needs to be located close to the process, like DCTRs and DVTRs, and also like switching capabilities for disconnectors and circuit breakers. These functions can be hosted by lower cost sensors and actuators. Because of the more simple design of these devices, the lifespan is longer and the configuration is more simple. This results in longer mean time between failure and shorter times to repair. Next slide. There are many benefits in using virtualization in substation functionality. Because most functionality is located on a substation hardened server, local or remote access can be done using a simple web browser. A more secure, cyber-secure solution, for example with ENCS, is easier to implement because of having a central solution. Hardware platform independent means choosing the best hardware for the job, so you can freely choose your substation server. It's also ready for future software defined substation automation platforms, like for example the already mentioned Linux Foundation Energy CPath. Also, you can use a single tool for configuration via IEC 61850 SCL, for example, the LF Energy Compass, which supports vendor-developed plugins for specific configuration needs. And most importantly, the substation functionality is scalable without the need for additional hardware. Of course, in some cases, additional sensors or actuators might be needed, but when additional measurement functionality or protection functions are needed, these can be simply added as a virtual machine on the substation server. Also, redundancy is easily achieved. You can add a second substation server, and if redundancy in terms of different protection algorithms is needed, this can be achieved by choosing a second vendor. Also, adding additional traditional IEDs is possible, as in the end, all equipment exchanges information by standardized communication as defined by 61850. Next slide. Increasing and simplifying substation security by using SCL files as a basis for intrusion detection systems. An intrusion detection system is a system that monitors network traffic for suspicious activity and issues alerts when such activity is discovered. It is a software application that scans a network or a system for harmful activity or policy breaching. Any malicious venture or violation is normally reported either to an administrator or collected centrally in a security information and event management system. Such a system integrates outputs from multiple sources and uses alarm filtering techniques to differentiate malicious activity from such alarms. For specification and configuration of secondary systems and substations, IEC 61850 provides the well-known SCL, the system configuration language. And in the SCL files, information is present regarding communication between various system components. When we know who should be talking to who, we can monitor this communication and report when suspicious communication is seen on the network. both from within the substation, but also from external sources. The examples shown here are from an SCD file. As you can see, there's a lot of communication parameters available that can be used by an intrusion detection system. For example, IP addresses of IDs or virtual applications or destination MAC addresses used by sampled value publishers. Next slide. By feeding the substation SCD file to an intrusion detection system, the system model can be compared against the live communication happening on the substation network. In case of malicious communication or unknown or unauthorized access on the substation network, mitigating measures could be taken and alarms or reports can be sent to security personnel. But Jérôme will tell more about this later on in this presentation. This concludes for now my part of this presentation.
Great, Edwin, thank you so much. I would encourage the audience to post their questions for Edwin. We do have a few minutes to take questions specifically for his presentation. And also just to let you know that this webinar will be recorded and shared with you at the end so that you can share it with your colleagues who may not have had the chance to register. So do we have any questions for Edwin right now? No, not for the time being. Okay, Edwin, thank you so much. We shall let you take your seat in the audience and then we'll have you back at the end to take any final questions.
Okay, thank you.
Okay, so now calling up to the screen, I'd like to invite Joss Zenner, Managing Director and CTO at Welotec. Thanks for joining, Joss, and over to you.
Thank you very much, Mandana, and also thank you, Edwin, for the nice presentation about new substation and digital substations. We heard a lot about software that is running now in substations instead of boxes like IEDs. So if we run software, we need to make sure that the software is running on very reliable hardware as well, because we need to meet the reliability that we are aware of from RTUs, protection relays, IEDs, but also firewalls and other equipment. So if we deploy software, we need to make sure that we deploy it on the same hardware specification as the box solutions in terms of robustness. The reason behind this is that substations are usually unmanned. They're operated in harsh environments. We have a very high EMC level. They need to operate at any time without failure. This is why if we do software solutions, like, for example, the one that Edwin showed for critical protection, merging unit, and other functions, but also if we do that for intrusion detection systems and firewalls, we need to make sure that the computing platform with those critical applications for the substations delivers the same reliability or even better reliability in extreme environments than IEDs and the devices that you know already. Next slide, please. So for this, we have standards, and those standards are defined, for example, in 61850, and especially the IEC 61850-3. And in addition to that, we also have the IEEE 1613 standards. And those standards define not only the requirements for environments, but also how system can operate and how communication should work and how reliable communication of those equipment should be in substations. So we're talking really about hardware specifications and that those devices can withstand the different varieties of the environmental conditions, especially, and that's why the hardware really has to be built to be used in substations, the high EMC levels and that are there through electrical interference and so on. They need to withstand harsh operating temperatures, because usually they especially need to work perfectly in situations where we have very cold temperature or very hot temperature. So from the specification, they need to operate maintenance-free from -40 to +75 degrees. And what's also very important is that they are not only rugged in terms of EMC and operating temperatures, but that they can withstand also vibrations and shocks, for example, through earthquakes or other events that might give some kind of shocks to them, like explosions or something like this. Next slide, please. So if we are going for a substation server and we have a very rugged device that can be used in substations and meet the same requirements as IEDs, we can, in digital systems, we can use it for virtualization. Virtualization means that I run multiple applications that are usually coming in different boxes on a single host. So in a 61850 systems, you can use that virtualization to replace multiple boxes like HMI, like RTU, but also merging units, or the software of the merging unit, the IDS system, so intrusion detection system, and so on. This will definitely reduce your cost. It will reduce the resources that are not used. It will help you to speed up the provisioning of the full substation, but also, as Edwin mentioned before, in case of a repair, it will be extremely much faster compared to replacing IEDs and those traditional I/O plus computing platforms. It also makes it very easy to add new applications. This is especially needed if you want to do innovation or if you want to increase cybersecurity, which should be something that needs to be done quite continuously. So this means you can add new software without adding new hardware, which makes it very simple and fast and cheap to do. This means virtualization is something that is used in data centers, telecommunication, and other critical networks for decades. It can be used in substations because we can deliver the computing power on a reliable system now. And this increased availability and also improves the disaster recovery options. So on. Next slide, please. So if we are looking about virtualization in substations, we can do that on a substation server or computer, and we can virtualize multiple different applications. In general, we group them in 3 different categories. First category is cybersecurity. We learn a little bit more about the IDS later, but we can also virtualize firewalls, or, for example, Active Directory for user access and user authorization. So this is very important to increase the cybersecurity because we are in a digital system now. So we need to take a well, more careful look on it. And we need to do that regularly, and probably we need to have and add new functionality the next year or a year later because new threats might emerge. In addition to that, we have the virtualization of station bus applications. This is something quite traditional already. It is done in many projects, and many energy companies are using our servers to do that already. For example, for HMI software, for RTU software, or Engineering Workstation. So what we have seen already is that I can put all those different functions and the work even better than before on a single hardware platform, which is multifunctional. In addition to the station bus applications, we can also extend that, and that was what Edwin showed before, to protection and control. So what we can do is we can have virtual machines or even containers running virtual protection functions, or virtual measurement, or virtual merging units. In this case, we need to make sure that the hypervisor that's underlaying and running all those applications is also real-time capable. So the red boxes that you can see there are for real-time applications. And this is possible, and we do that together already. Okay, perfect. I think I'm at the end for this short presentation now. If there are any questions, over to you, Mandana.
Thank you very much, Joss. We do indeed have one question, and that is, one single server will be enough to run all the required applications which are running inside independent equipment. Is that correct?
It depends. So usually what you definitely do is that you have two servers for redundancy, and then you need to check how much resources each application needs. There are different versions of the server that you can use. Usually what we have, or what we see in the field at the moment, is that we have one server or a set of two for redundancy purposes for the cybersecurity. We have a set of two for the station bus applications, like HMI, RTU, and Engineering Workstation. And we have a set of two for the protection and control functionalities for the real-time functions. But technology is evolving very fast. So next year we'll launch a server that can or delivers more than twice the speed of the existing servers. And then starting from 2024, there will also be even faster servers to have also the capability of very advanced AI applications inside of substations.
Yes. We have another question for you, and that is, shielded LAN cables should be earthed at one of the IED or both ends of the LAN cable to avoid EMC effects in substations.
Well, that's a very difficult question. I'm not an expert on this, but usually the IEDs are not directly connected to the server. So we have switches in between for redundancy purposes for the network. So this would be a communication between the IED and the switch. I'm not sure if any of the other can answer that question better than I can. Probably jump in.
I will have an example about this in a minute in the IDS presentation.
Okay, perfect. Yeah. So we'll have more. So yeah. So if there are there more questions or?
Yes, we have one more. Virtualization of cybersecurity. Do you mean software firewall? Software firewall installed in the IPC with complied with 62443?
Well, yeah. So what you can install is a software firewall. You can install software IDS system. Jérôme will show that later. You can install Active Directory. You can install log server. You can also install something for physical security, like video surveillance applications. In general, the IEC 62443 defines the full scope. So you always need to look what you need to do in that for the end-to-end cybersecurity. And with the firewall, you do a quite good step, but without the IDS system, it will be very difficult to achieve.
Now, Edwin spoke in the first presentation about incident response actions. Are you planning to provide incident response playbooks, or do you let this be with existing SOAR systems, SOAR systems?
Very good. I will hand over that question to Jérôme. I think it's more on your side. Is that correct?
Yes. So incident, first of all, good morning, everyone. Incident response has a few aspects. There is the thing we think about first is how do we react when there is an incident? So the emergency team, and yeah, this is contracted with a security company. But there is also the aspect of what information do we have that we can give this security company to investigate, react, stop the incident. And for this, we need to be prepared before with a lot of logging activity, which is also required by 62443, logging security events, failed user login, but also disk usage capacity reached, and also what's happening on the network, which will be a good transition to the next presentation.
Okay, I think this is a good point in which to wrap up. Thank you for your input there, Jérôme. Thank you for your presentation, Jos, and your insights. So Jos, we'll ask you to take your seat back in the audience, and then introducing Jérôme Arnaud, Head of Product Management at Rhebo. Thank you very much, Jérôme. Over to you.
Thank you, Mandana. Yes, welcome everyone to this short presentation about how the intrusion detection system can support the challenges with 61850. So yeah, let's move to the next slide. And to the next slide. Thank you. So yeah, just as a recap, yeah, before 61850, everything was hardwired and it had its own challenges. But one thing was that everything was hardwired with is one signal per wire. So if you were to investigate a mishappening, your multimeter you would use your multimeter on this wire and get a sense of the signal quality. Now, if you look at the next slide, of course, with 61850, everything is digitized and everything is on a single wire, which is the Ethernet cable. And all of the analog IOs and digital IOs, all the process values are on this single cable. But not only that, now there's other signals, everything that is needed to make this communication network work, actually. The time synchronization, what we call the control plane of the network, the authentication protocols like LDAP, some file transfer protocols to send the configuration to the IDs. This makes it seem a little bit complex. And the question is, where is your multimeter now? How can we measure the quality of the signal and the quantity of the signal? So if we move to the next slide, we add to this change in operation the new aspect of the cybersecurity threat. And we discussed about cybersecurity, about authentication, about a firewall. But a firewall is necessary, but it's not enough because, well, the network isn't the only threat vector to the system. So we learned about supply chain compromission with the SolarWind issue a few years ago, but we also can do configuration mistakes, including mistakes in the firewall. We have to remember that this is a long-term activity, not just a commissioning activity. So we must ensure security for 5, 10, 15, 20 years. And even if we test the configuration at commissioning time, how do we ensure that this security configuration holds up over time. So if we go to the next slide, then, yes, we can go to the next slide. Yes, then we need to not only look outside for whoever tries to get in, but we also need to look inside what's happening to detect security breaches and to look for quality issues in the communications. And that is the promise of the network intrusion detection system. On the next slide. And then, so the promise is visibility on the network by understanding or seeing every communicating device, detecting vulnerabilities, and detecting anomalies and threats on the communications. And so how do we do that? Let's look at the next slide. This is an example. So we see a big globe. So that's one of our customers. He's got a large system, which is working. The process is working well. But by doing a network assessment, we see a few, I would say quite a few red spots. So looking deeper into this, we found out, I would say, many TCP retransmission, many TCP quality issues, and this can be tracked down to a faulty Ethernet cable. And in that case, a failure in the grounding of the Ethernet cable, which is not a total failure, but which creates some communication incidents every now and then, which creates TCP retransmissions that we detect. And so, even though the process was working well, it was, well, fragile and perhaps on its way to fail at a certain time. So there's, I would say, we need to look at what is not completely obvious. So let's go to the next slide. This is another example of what you can see with your digital multimeter, with your network intrusion detection system. This is traffic patterns. So we filtered a few protocols. And so there's, in the top example, the green is MMS. So there's I would say, consistent pattern in MMS traffic. But what is obvious here is there's a sudden spike in FTP traffic and a sudden spike in SMB traffic on September 24th to 28th. So yeah, that's also worth investigating what's happening in the system in those 3 days. Is it, I don't know, a large backup transfer, a transfer of a backup? So this would be expected. Is it a large transfer of, I don't know, configuration file updates for IDs? Or is it someone extracting data, and leaking data? So with your digital multimeter, you see this in real time if you look at it, but also because this type of incident is then automatically recorded by the NIDS. In case you need to investigate after the fact, well, then you have the data recorded. And this is also what's important for incident response. When you need to investigate where the incident came from, you need data points, and the IDS records the network traffic. So you can go back in time and look at what was happening on the network at the moment and before the incident. The graph below shows a pretty radical issue, which is, well, at some point on September 22nd, the goose traffic stopped. Okay, so in that case, I expect the process control system to detect this also, of course. But again, in less critical incident, we could see a pattern where the goose traffic would degrade, in which case we could investigate before it actually stops on the system. We can move to the next slide. So yes, I was talking before that it's not only the process traffic that we see on the wire, but also other type of protocols, sorry, of traffic. So this is an example for a customer that we monitored for, I mean, it's a result of a few days of monitoring. And so we see the main protocols are process, TDS, IEC 104, GOOS. But there's also, file transfer with SMB, syslog for logging events, file transfer with FTP, HTTP unsecure, then HTTP for probably UI, user interface things, and a few protocols that needs to be investigated. What is this custom protocol that has quite a high traffic? So yes, you have visibility, and this is an extract. With any customer, we find between 20 and 50 protocols being used on the network. And that allows us to also find all those data that are not needed, but are the results of default configurations. And then we can advise our customer to remove those to have a much cleaner and resistant network. Let's go to the next slide. So what you will find also are the unsecure protocols. So I'm sure most of you expect those because the control, I would say many industrial control systems were installed at a time where cybersecurity was not such a big deal, and they live on forever, I would say. But still, when you look at your network and you can actually read the password, going through in terms of awareness, this still raises some question. And so, of course, we redacted here the IP addresses because this is actual data from an actual customer. But yes, you will detect with your IDS the secure protocols and the passwords going over the network. Next slide. So how does detecting anomaly works? Well, the principle is quite easy. First thing is to establish a baseline of what is normal, then or expected, then continuously inspect traffic and report deviation from the baseline. And how do we do this with 61850? Edwin mentioned this at the beginning of this webinar. We can use the SCD file because this file in 61850, it describes the full communications between 61850 IDs and endpoints. So if your MMS server or MMS client or Goose publisher is not defined in the SCD, it's an anomaly, and then you can report this. Next slide, please. So yes, we've seen this pretty much already. So you've got your SCD file and your capture frame, and you match the different attributes in the bucket to the SCD, your MAC address, your VLAN ID, your app ID, your Goose control block, Goose ID, etc. And then you can report if this is seen on the network and not defined in the SCD. Next slide. And so what you get is, yes, again, this looks like a CIA report, heavily redacted, but again, I'm protecting customer data here. But then, yes, you will get, for example, in this case, that this 650 communication, so this data set, this control data set between this MAC address and this multicast destination is unexpected, so it was not defined. So then you can investigate if this is a rogue device or if it's a ID misconfiguration. Next slide. Yes, this is another example with MMS. Again, so this is test data, so it is less redacted. But yeah, you can see my ID and my IP address are not supposed to talk MMS. Or I would say the server and the client are not defined as MMS endpoints in the SCD. So again, this is an anomaly. Next slide. And yes, so this is great because you can, with this, we can precisely monitor 61850 communications, and with very little effort, because the SCD file, which is a lot of work to create, it is actually there already because it's been created for the electrical substation. So we just reuse, we get even more value from this file that was so difficult to design and engineer to monitor what's happening. And it's really a deterministic baseline. It's not based on guessing or observing, or in that particular case, I mean, it's defined. So it is also very easy to get back to the source problem. So, and this reduce the burden of the analysis. Another way to reduce the burden of the analysis is that with this approach, we sort of bridge the gap between the OT person, the substation person, and the security analyst, because now they speak the same language. If the security analyst goes and says, "Hey, MAC address X has an unexpected goose with MAC address X," this is not super clear. But if the security analyst can say, "Hey, I have this MAC address is an invalid goose publisher, and I can see that this MAC address is associated to this IP with this ID name," oh, then this information is actionable by someone which is not a security analyst and but is a process control specialist. And as I'm sure you guessed so far, in addition to security, this can be used to troubleshoot communications. You expect endpoints to communicate, you can actually see. So this is sort of the multimeter apart, if the signals go through or not, and if it's of good quality. So it's also a 650 troubleshooting tool. So I think I will skip the next two slides and go to the questions.
Thank you very much, Jérôme. So do we have any questions for Jérôme before we go to the panel? None so far. So I'm going to ask our other speakers to come back on screen and join us for a short discussion to finalize and wrap up the session. Edwin, Joss, thank you for joining us. So any questions for the panel as a whole? Okay, whilst we wait for that to come through, I have one question actually. At Smart Grid Forums, as you know, we do a lot of research into the 61850 market, and we talk to the utilities quite frequently. Virtualization is right front of mind for people at the moment, so it's a very hot theme and very timely to be talking about that. From the conversations that you all have with the market, how far away would you say virtualization is in terms of mass take-up among the European utilities? Do you have any idea of timelines?
Well, maybe I start with that. So I believe virtualization is there already. The question is if it is there for real-time applications like protection and control, or if it is just for cybersecurity and non-real-time applications like HMI and gateway. So for HMI and gateway and firewall and IDS, we do that since several years. And we see that this demand is continuously growing and really ramping up. For real-time capable applications, it's still something new. So we did a few projects and studies together with Locamation. We also work together with vendors in creating that kind of solutions. There are also some kind of demo projects established, but it's still something, at least from my perspective, which is just ramping up and will come in the next 2 years into demo and small scale deployments, and then probably in larger scale deployments, and with some kind of migration path. So we will start with measuring mainly, and then going into also protection functions. That's at least what I'm seeing. Edwin, you want to add something? I guess yes.
Yeah, of course. Yeah, I think it all starts with a good process bus solution. So we need to have good, secure, reliable sensors and actuators that convert process information into usable signals and streams. So that is very important, because on top of that you can create new applications that do that perform protection functions or control functions. So I'm very happy to see that we have some contacts with SDOs and DSOs and TSOs that are investigating in this field and really putting a lot of effort into it to see and make it actually work. So it's very important that these projects are happening to see what the benefits really are of these centralization and virtualization schemes. So in terms of a time frame, that's very difficult to say. 61850 is already around for more than 20 years. Also, the process bus definition is already around for 20 years, so it's not new technology. It's already existing for a long time. And I think it will only, it will be a matter of time and the willingness of the end users to step into this field. But we see a lot of good projects going on in terms of development of application, development of configuration tools like Compass that will really add to the success of this process. And maybe adding also, maybe some parties are reluctant and say, yeah, but who is responsible for having a virtual application, or how about security? There are a lot of valid questions in this field that we need to address and that are being addressed at the moment, and that will also be solved. So for me, it's only a matter of time that this will happen. And I'm not the only one who is saying this. There are some renowned people in this industry that even take this much further than virtualization. But it's difficult to put a time tag on it. It will not be tomorrow, but it will also not be in 15 years. It will happen quite soon.
So I can add a little bit to that also. I would say that for the non-real-time application, yes, we see a lot of deployments. I've witnessed lots of deployment in the offshore wind farms, where space is at a premium. So before we would install 20, 30 PC computers in the substation for the different applications. And with virtualization, this can be consolidated in one cabinet in the 2 separate control rooms that are on the platform. So space being extremely expensive on an offshore platform, virtualization in that particular case is very well suited. For the real-time applications, yes, I'm completely agree with Edwin and Jos. There's also a huge benefit with virtualization for cybersecurity in the terms of disaster recovery, because once you have a central scheme, I mean, as a central system in a few, I would say, servers, and your system goes down, it is so much easier to restore virtual machines and get back online than to go to every ID and, I would say, reflash a firmware, because we lost confidence. Okay, if an attacker went into a PC, are we sure he didn't go into a protection relay? So after we lose confidence in the system, getting back online with virtual machines is a matter of minutes, and you could keep those backups offline, completely offline. You could build a cabinet that you bring back on site and be ready in a very small time frame compared to rebuilding a system in a conventional substation.
Thank you all. And so it seems that the biggest risk is for the real-time applications, in which case, what is the single biggest issue that perhaps if we think about mitigating that now as a community and within the working groups, that could really fast track the deployment of virtualization for real-time applications?
Well, I can start with that. So, I mean, the biggest issue that we have at the moment is that no product is 100% ready or covering everything. We have the computer hardware, which is there. We have the hypervisors that are capable of real-time applications. We have sensors and actors that can be used, because you still need IOs if you virtualize protection and control and visual measurement. And then you have, for example, from Locamation, you have virtual merging units, but still the protection functions are not available from a vendor that is offering them in a production-ready solution. So as soon as those things are really available and being rolled out and trialed, then I believe it will get very fast.
Any further thoughts on that, Jérôme, Edwin?
So, go ahead, Ed.
Yeah, I think what Jos is saying is true. Some things are still under development, but things go very fast, especially because you don't need to develop new hardware. This is a big advantage in developing new functionality for substation automation. It's all virtualized. Yeah, we like you said, we have a virtual merging unit now and sensors to go with that. We are now developing also a measurement application that converts sampled value streams into measurements that can be used by control centers. And we already see that this is going very fast. The first results are already there, and it's very promising. So yeah, it will only be a matter of time that other companies will develop functionality for substation automation as well. And even some companies have these solutions already available for a long time. For example, a gateway from 61850 to DMP 3 or 101, 104, sorry. They have this functionality available, but previously it was installed on a separate computer. But now they can easily put this in a virtual machine and install this on a substation server. In the last 61850 week, I got a question from one of the companies exhibiting there. That they were looking for some piece of hardware for their solution. So they are already sitting on the solution, but they have no idea yet they can also virtualize this quite easy. So yeah, and of course it's very important that some end users, some DSOs do real research projects with this and see what are the pitfalls, what about the performance, what about the reliability. Of course, this is important.
Yes, I think utilities are very keen on developing this technology. They are very keen on implementing centralized protection. And today, centralized protection is a piece of hardware, and it's limited in the number of algorithms it can run. And so virtualization is the next step. The barriers are, I would say, usually utilities are very careful when they introduce new technologies, so they need quite a lot of trials on the field. And also, there will be a mix and match of vendors in one virtualized environment, and the vendors need to trust the other vendors to not break the environment. The utilities need to trust the vendors to play nicely with the system. And so it will take a lot of trials, demonstration, interop tests to bring this so that everyone trusts this new approach. But we shall be optimistic because the benefit is so high for the utilities that they will be pushing this. It will take a few years, but this is the way.
Great, thank you. I suppose the final question would be, do we feel that there is enough of a focus on virtualization within the working group activity, or do we have any suggestions of what the working group could be looking at to help fast track this as well?
The working group, you mean which working group?
The 61850 working group.
Okay. I'm not sure if there's any activity on that. I haven't asked Mr. Brunner, but yeah, it would be a good question. Of course, 61850 is already designed to be to work in a virtualized environment, because you can freely allocate your functions anywhere, and this is one of the first goals of 61850 already for a long time. So I would say centralization, virtualization is already embedded somehow implicitly in the standard. I don't know of any explicit activity on virtualization in 61850, but maybe the other participants do.
I don't know, but yes, 61850 was made for this application. The current architecture, where we have digitized data, but still individual piece of hardware, is an intermediate step. But the digitization of the data and the communications eventually will lead to the virtualization of the algorithm also. So we are in a transition, I think.
Yeah, exactly. So, for example, a sampled value stream or a goose message is actually a virtualization of primary process signals. It's already virtualized. So, yeah.
I would agree. And if you're looking into other industries, so first in IT, which is doing that type of things since decades, or telecommunication, which is also very critical infrastructure. With 5G networks, they're going for virtualization and they roll it out. And I think it's the biggest innovation within 5G is not speed or latency or something like this, but it's that they're using virtualization and open technology and have it software defined. And if the telecommunication industry, with all the different players, that is very similar to the energy industry, at least, is doing that. I strongly believe that also in the energy industry, this is just a matter of a few years more.
Thank you very much. A big thank you to all of our speakers today, Edwin, Joss, Jérôme, and to the team at Rhebo for organising this opportunity for the community to learn more about the real-world practicalities of implementing 61850. The webinar recording will be made available shortly, so please do share it with your colleagues who could benefit from this information as well. And the next in-person opportunity to learn about 61850 will actually be at the SG Tech Week 2023 conference, which takes place in March in Amsterdam. And this is where Christoph Brunner, the convener of the 61850 working group, will be presenting and also providing some training. We also have a 12-week online training program on 61850 at Smart Grid Forums for anybody who's right at the start of their journey and would really appreciate a paced out training program that's online that will fit in with day-to-day work quite easily. So if you do wish to join us on either one of these events, please visit the website at www.smartgrid-forums.com, and there you'll see a complete list of our events, both online and offline, for the next year. So thank you once again for participating and interacting today. Wish you all a great day and look forward to seeing you all on the next webinar very soon. Thank you. Bye for now.
Thank you very much. It was a pleasure.
Thank you. Bye-bye.